Nitric acid. It's a very important oxyacid of nitrogen, and it is also a very important commercial acid. Nitric acid is mainly obtained in the lab by treating any of the nitrate salts with concentrated sulfuric acid. It directly forms nitric acid. In industrially or commercially, it is obtained by a process which is called Ostwald's process. In Ostwald's process, ammonia is catalytically oxidized to nitric oxide and water. Now, this catalytic oxidation is done in the presence of platinum or rubidium gauge as a catalyst at 9 atm pressure and 500 Kelvin temperature. This nitric oxide obtained, when this temperature of this is allowed to cool down, it combines with oxygen to form nitrogen dioxide. This NO2 is then passed through water, which gives nitric acid and small amount of NO, which is actually recycled back to combine with further more of the oxygen to form NO2, and this is how we obtain nitric acid. The nitric acid thus obtained by the Ostwald process initially is, remember, is 68% by maximum pure, because we know that at 68% with water it forms azeotropic solution. Now, in order to make it about 98% pure, it is treated with sulfuric acid, which is acting as a dehydrating agent and removes the rest of the water. Now, its properties. Remember, it's a colorless oxyacid of nitrogen with density specific gravity 1.504 gram per cc, and its boiling point is around 86.2 degrees Celsius. Now, it's highly soluble in water, and we know that it forms a lot of H3O plus and nitrate ion. So, it's a very strong acid in that way. It's a very strong oxidizing agent. Remember, even it is more strongest oxidizing agent than sulfuric acid. So, it oxidizes a lot of non-metals and metals to their corresponding oxides and oxyacids. Let's take iodine. When iodine is treated with nitric acid, it oxidizes it into iodic acid and forms NO2 and H2O. When treated with carbon, this nitric acid oxidizes it into CO2, H2O and NO2. When treated with phosphorus, nitric acid oxidizes it into phosphoric acid, H2O and NO2. It oxidizes sulfur to sulfuric acid, forms nitrogen and water. So, all these are its strong oxidizing actions, in which it is showing what? That it is reacting with these non-metals and correspondingly oxidizing them into their oxides and oxyacids. So, this is how it shows that how strong its oxidizing action is. Simultaneously, it can oxidize the metals also. It can oxidize metals like if we take copper or zinc, and if we treat it with dilute nitric acid, remember it shows its oxidizing nature both in dilute as well as in concentrated medium. With dilute nitric acid, of course, it forms copper nitrate, but along with this it forms nitric oxide and water. whereas with zinc it forms zinc nitrate, nitrous oxide and water. So that's the difference here, that with copper it forms nitric oxide, with zinc forms its nitrous oxide. Whereas when these same metals are treated with their concentrated nitric acid, it forms corresponding nitrate and releases NO2 and H2O. And the same reaction takes place with zinc, where it combines with zinc to form zinc nitrate, NO2 and H2O. So these are its reactions in which what we find is that it is acting as an oxidizing agent for metals also. Then at the end, we have the most common ring test of the nitrate ion. See, nitrate ion in salt analysis, I am talking about ring test, how it is tested. This nitrate salt solution is treated in presence of freshly prepared ferrous sulfate solution, is treated with concentrated sulfuric acid, which oxidizes ferrous to ferric and forms what? Nitrate is converted into nitric oxide and water. Now this ferrous ions which are already there were present in the form of this complex hexa-aqua Rn2. The nitric oxide combines with this and forms this complex, which is called penta-aqua nitrosonium Rn1. So see, this is a very special compound. This is the brown ring which we get, which is formed at the junction of the sulfuric acid and the salt solution, because sulfuric acid being higher, having higher densities, moves down, and the junction at which these two liquids forms, this complex is formed, because of which the brown ring is formed. Now this complex is having a very special property in the chemistry, because very special position. The reason is because the iron in this is present in the +1 oxidation state, and this nitric oxide is present in the form of a positive ligand, the nitrosonium ion. So that is why the overall complex is having a +2 charge, and it is called penta-aqua nitrosonium Rn1. So this is why we have this special compound discussed here, in which is formed by the use of this nitrate salts.